This is Mrs. Fraser, and we'll be going over your Unit 5.1 test review. So here's some factoring tips. As you're preparing for your test, don't forget to take out the greatest common factor first. It's okay if you don't take it out first, but it always makes it easiest if you do. Look for easy ways to factor when possible, such as the difference of two squares or perfect square trinomials. And remember our standard form to factor it using our area models, that we place our ax squared in our first left top box. Our c is placed in our bottom right-hand box. And then these two middle boxes make up my x value. And these two numbers, these are two numbers that multiply to equal the same as a times c, and add to equal my middle term, b. Okay, so we are going to factor the following using different methods. So looking here at number 1, I have x squared plus 6x plus 9. I'm going to look for some of the patterns that we talked about before. So first I notice that this can be divided by 2 evenly. This is a perfect square. And my first term is also a perfect square. So this is actually a perfect square trinomial, meaning my factors will be x plus 3 squared. Okay, number 2. Okay, looking at this one, it looks different than things we have looked at, but I can actually see that all of these are divisible by 8. 40, 56, and 56 are all divisible by 8. So first I'm going to take a greatest common factor out of 8. So dividing everything by 8, give myself a little more space here. Okay, dividing everything by 8. Now I have 5m squared n plus 7mn squared plus 7mn. Okay, so another common factor I can see that all three have is m. Okay, so now I can also take out m. So I have 8m as my factors. So dividing every single one by m, now I have 5 m n plus 7 n squared plus 7 n. And then finally, I can take out one more greatest common factor, and that's n. So now I have 8mn as a factor, and I'm left with 5m plus 7n plus 7. Okay, number 3, first looks like that I might be able to take out a greatest common factor. So it looks like I can take out a greatest common factor of 4. So I'm going to divide all pieces by 4. So I have 4 x squared plus 7x minus 15. Okay, so now I'm going to factor the piece that's inside my parentheses. So 4x squared belongs here in negative 15. And then I'm looking in these two boxes for two numbers that multiply to give me negative 60 and add to give me 7x. So let's just start with the negative 60. So breaking that down, I know I have 30 times 2, 20 times 3, 15 times 4, 12 times 5, and I think I can stop there. So I'm trying to make 7. So, and I need to multiply to get negative 60. So all of these need to be negative to make negative 60. So 12 minus 5 is 7. So I'll have 12x and negative 5x. Okay, so finding my factors, I'm going to take out a 4 from the 4x and the 12x. Actually, I'm going to take out a 4x. So this will need to be x, and this will need to be 3. This will need to be negative 5 to make negative 5x. So my factors, don't forget about my greatest common factor. So I have 4 times 4x minus 5 times x plus 3. Okay, number 4, looking at my what needs to be factored here, I can see that I have a perfect square. I have subtraction, so I have a difference. And I have another perfect square. So I actually have the difference of two squares here. So I can write my factors as r plus 5 times r minus 5. Okay, number 5, 2x squared plus 5x minus 25. I don't see any greatest common factors, so I'm going to go ahead and start factoring. 2x squared will need to be placed here in negative 25. So I'm looking for two numbers that multiply to give me negative 60 and add to give me 5x. So let's find our numbers that multiply to give me negative 50. So I, of course, have 1 and 50. I have negative 2 and 25. I have negative 5 and 10. And negative 5 and 10 also can make me positive 5. So negative 5x and 10x. I'm going to take out a 2x from the 2 and the 10. So this will need to be x, and this will need to be 5. This will need to be negative 5 to make negative 5. So my factors are x plus 5 and 2x minus 5. Okay, number 6. Hopefully you're starting to see a little bit more patterns when you're looking at these. but I can see that this first number here is a perfect square. I can see that this one can evenly be divided by 2. And this is also a perfect square. So I might go ahead and do my perfect square trinomial, but if I'm struggling, I can remember we can go ahead and do our area model, which a lot of you are doing. So I'm going to go ahead and do that for this one. So I know this will need to be 9x squared, and this will need to be 1. And I know I'm looking for two numbers that will multiply to equal 9 times 1, which is 9, and add to give me negative 6. Okay, so I have 1 times 9. I have, or and I have negative 1 times negative 9. I have 3 times 3, or I could have negative 3 times negative 3, which is actually what gives me negative 6. So I have negative 3x and negative 3x. Okay, so I know that this will need to be 3, and this will also need to be 3. So I have 3x and 3x. And this will need to be minus 3, and this will need to be minus 3. And I realize I just made a mistake on my key, because this is actually not a perfect square trinomial. So this one's actually going to have, this actually cannot be factored. So I made a mistake on my key on Canvas that needs to be fixed. So this one cannot be factored. So even though I found two numbers that can multiply to give me positive 9 and add to give me negative 6, it's not possible for those two numbers to multiply to give me this positive 1 here. So that's a problem. So that's not going to work this time. And I can see that those factors are not working to create that trinomial. So this one cannot be factored, or we might say it's prime. Okay, so let's move on to solving quadratic equations. This is very important to remember when you are solving quadratic equations. You are solving for the x-intercept, or when y equals 0. So we're not just, when we're factoring, we're finding our linear factors that create our quadratic function. But when we're solving, we're actually solving for when y equals 0. So that's why we actually set our equations equal to 0 when we are solving. Other names used for the x-intercept are zeros, solutions, and this is one that you might not have heard a lot, roots. And this largely comes from your quadratic formula, but also just from the format of your quadratic, ax squared plus bx plus c. It's the squared term. And to undo a square, we always have to find the square root. We're finding the length of the sides of a square that make up this quadratic formula, right? So I really am finding the roots of my formula. So you may see these three terms on your test. So let's match the best method for solving quadratic equations to each explanation. Now, we know that many of these methods can be used even when it's not the best method, and that's fine. You're perfectly, you can use those methods still. But we want to start trying to look for patterns to use the fastest method and the best method for that. But of course, use the method that you need to use at that time, and if you are strong with that method. Okay, so number one, this method is best when the coefficient to x squared is 1, and the solutions can easily be found using an area model. So when I'm using my area model, that's when I am typically factoring, so C, okay? And that is best, so for an example, x squared plus 4x minus 12. I have a coefficient of 1, and I can easily set this up in an area model and solve. Number two, this method is best when there is no bx term and one or both of the remaining terms are perfect squares. So for example, 4x squared equals 25. I can easily, I can look at these. Or when one side of your equation is already factored to a perfect square. So like x plus 2 squared equals 17. And this one's best used with our square root method. Number three, this method is best when the coefficient to x squared is 1. The middle term can be divided evenly by 2, and it is not possible to solve by factoring. For example, x squared plus 4x minus 17. So if I can't solve this, solve for x by factoring, and I already have a coefficient of 1 or middle term, the best one to use is completing the square. And number four, this method is best when the coefficient to x squared is not 1, the middle term can't be divided by 2, and it is not possible to solve by factoring. So when my quadratic equation is a little bit more complicated, so like 3x squared plus 2x minus 12, I might use my quadratic formula. So just another reminder, remember when we set quadratic equations equal to 0 when solving, because we are solving for the x-intercepts, or when y equals 0. Okay, so we are going to solve each quadratic equation using the method you chose from above. So these are the examples from above, and we're going to use the methods that we suggested from above. Okay, so for on this first one, we're going to use factoring. My coefficient is 1. And I'm going to set up my area model to factor. So I have x squared and x. That means this must be x times x. Okay, I'm looking for two numbers that multiply to give me negative 12 and add to give me 4x. So I have 1 times 12, or negative 1 times 12. I have negative 2 times 6. And 6 and negative 2 also give me positive 4. So I can place negative 2x and 6x. If this is 6x, then this must be 6. And this will need to be negative 2. So my two linear factors are x plus 6 and x minus 2. And I'm going to set both of these equal to 0. And I'm going to solve for x, my x-intercept. So x plus 6, I'm going to subtract 6 on both sides. So x equals negative 6. And x minus 2, I'm going to add 2 on both sides. So x equals 2. So I can write this as x equals 2 comma negative 6. Okay, number 2, above we chose the square root method to solve. And that's because both sides are perfect squares and I can easily square root both sides. So I'm going to square root 4x squared and square root 25. So I'm left with 2x equals plus or minus the square root of 25. Okay, so I'm going to write this 2 times because I have 2x, because the square root of 25 is 5. So really it's 2x equals um, positive 25. I'm sorry, positive 5. And 2x equals negative 5. Okay, so I'm going to divide both sides by 2. And I'll be left with x equals 5 over 2 and x equals negative 5 over 2. So remember, we can also just write that as x equals plus or minus 5 over 2. Okay, number 3, I can see that my first term is 1. If I try to factor this, which I can do, okay, trying to factor x times x is x squared, I'd be looking for 2 numbers that multiply to give me negative 17 and add to give me 4. So I kind of stop really quickly because the only factors I have are 1 and 17, or negative 1 and 17, or I have 1 and negative 17, and none of these make positive 4. So immediately I should see that I can't factor. So that's when I either need to use the quadratic formula or completing the square. And we talked about that completing the square would be best here because it has a coefficient of 1. So I am going to go ahead and place this on the other side of my equal sign. So I'll have x squared plus 4x. And now I'm going to end up adding something here to complete my square. And I'll have positive 17 on the other side after adding it to both sides. Okay, so now I'm going to complete my square. I know that this will need to be x times x to make x squared. I know that this will need to make up and make 4x, so this will need to be 2 and 2, meaning this will need to be 4. So I'm going to add 4 to both sides. Okay, so my left side we've already factored now, so I know my factored form is x plus 2 squared equals 21. And now I can use my square root method. So I'm going to square root both sides. I'll be left with x plus 2 equals plus or minus the square root of 21. And then I need to subtract 2 from both sides. So I'll have x equals negative 2 plus or minus the square root of 21. And this is my final answer. Okay, number 4. I can see that the left side can easily be solved with a square root, and I already have 17 on the other side, so I'm just going to use my square root method here. So square roots, both sides. I'll be left with x plus 2 equals plus or minus the square root of 17. And then I need to subtract 2 from both sides. So I have x equals negative 2 plus or minus the square root of 17. Okay, so number 5 is my last method. So to check to see if it can be factored first, I would multiply 3 and negative 12, which would give me negative 36. So I'm looking for two numbers that multiply to give me negative 36 and add to give me positive 2. So 1 and 36, or negative 1 and 36, negative 2 and 18, negative 3 and 12, negative 4 and 9. And I could keep going, but hopefully you're seeing that there's no numbers, because the next one would be negative 6 and 6. There's no numbers that will give me 2, so it can't be factored. So I'm going to use my quadratic formula on this one since my coefficient is 3. And completing the square would be rather difficult with this one. So my quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And it's best, I hope that we've learned that it's best to go ahead and do what's inside my square root symbol first. That's really important. So we're going to go ahead and take care of what's inside my square root symbol first. So b squared, 2 squared, minus 4